are you doing using your calculator?
I'm making sure I'm right.
On what?
My multiplying. I do it all the time. Like in a test, if it's like 1 times 4, like I do it just to make sure.
All right, you be you.
Okay, I do that too. I do it all the time.
Okay. All right. We'll finish that in a second. I need everybody to watch up here. All right. This is your equation. Now, I need you to understand one thing. If at all in any of your time for the rest of grade 11 and 12, you struggle with the graphing, then you can always go to a table of values, like what you're doing right now. You can always go to a table of values and then at least just plot those points and you'll get the idea of what the graph looks like. That is always your fallback when it comes to graphing. Just put a table of values in there. Now, I'm going to do this a little different. I'm not going to use the table of values. I'm going to treat this as a line, and I'm going to graph a line. Okay? So I'm going to graph this line. Y equals 2x. Where's my starting point? 0 and 0. So I start right here. Where does my slope tell me to go? Up to 1 to the right. Okay. So all along that red line, you have -4, -8, -3, -6, -2, -4, -1, -2, -1/2, 4, -4, -1/4, 8, -8, -1/6, -12, right? Okay. Then you have 0 and 0. Then you have 1/6 and 6, 1/4 and 4, 1/2 and 2, 1 and 1. That's an important one. 2 and 4, 3 and 6, and 4 and 8. Everybody's X values and Y values match there? Okay. So all of those coordinates are along this graph right here. Now, the very first thing you're going to do. So we now want to graph this. Now, there's two ways that they're going to write that. They're going to write it like this, or they're going to say, I want you to find this. Which means that no matter what, you're taking 1 over all of the Y values of your original graph. So you're taking 1 over all your Y values. Now, I'll go back to the table in a second. What you need to do right now is 3 steps, which I explained to you last week. The very first step is where that original line crosses the x-axis, I draw in what? What is that called? Starts with A. Asymptote. I draw the asymptote right here. Now, remember, you're going to take 1 over all of the Y values along this line. So what is the Y value on the line right here?
0.
It's 0. What is 1 over 0? It's undefined. So as soon as it's undefined, I need an asymptote. That's the first thing that you're going to do. The second thing you're going to do is find my 2 invariant points. The invariant points are the coordinates that are on the original and on the new graph. What is the one thing that you change that stays the same? So if you were to go through and do y equals 1 over 2x for all of those coordinates, what are the 2 that stayed the same? 1 and 1 and -1 and -1. Okay, so somebody tell me something. I'm now taking 1 over this coordinate right here. The y value of that coordinate right there is 1. What is 1 divided by 1? 1. And then down here I have negative 1. What is 1 divided by negative 1? Still negative 1. Those two coordinates are on the new graph when I take 1 over them. Now, finish your table of values for the second side there. For the y equals 1 over 2x. Finish that right now, please. So you should have negative 1/6, negative 1/4, negative 1, and then negative 1/2, negative 1/4, and negative 1/6. Right? And then on the other part, you're going to have 1/6, 1/4, 1/2, 1, 2, 3, and 4, right? Or is it 2, 6, and 8? 2, 6, and 8, I think. Okay. Fill in that right side. And again, the first two steps that I just gave you do not change with any graph. They do not change with any graph. Okay, so let's read those together again so that everybody has them. It was negative 1/8, negative 1/6, negative 1/4, negative 1, negative 2. Is that right? No. What's the next one there? Oh, yeah. That will be negative 4. I'm trying to do this in my head. Okay. That actually should be negative 1/2. Because it's 1 over that. 1 over that. And 1 over that. 1 over that. Okay.
So how is this?
Okay, we're having struggles here. Okay, just wait. Okay, let's do this together. X, f of x, 1 over f of x. Let's do it together so we get this right. Because I can't show you what I want to show you. Okay, so it's negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, and 4. Is that right? Okay. All right, so change this. This is 2x. So it's just twice that. Okay, so what's twice that? Minus 8, minus 6, minus 1/4, minus 2, 0, 2, 4, 6, and 8. Okay.
You forgot the fraction.
I forgot the fractions. Okay. My bad. Trying to rush this. Negative 1, so that's negative 1/2, negative 1/4, negative 6, 1/2, negative 1/4, negative 1/6. And I actually messed this up, so this is good that we're doing this. So then I get to 0, and then I go 1/6, 1/4, 1/2, 1, 2, 3, and 4. Is that right now? Okay, so let's go through this. So this will be negative 1/4. This will be negative 1/8, negative 1/12, 0, 1/12, 1/8, 1/4, 2, 4, 6, 8. Does that look right now? Everybody have that down? Want to use your calculator and check my math? You might have to. I'm not lying. Okay, so we got all of those are all down, and all I did was take my x value times my 2. Morning.
So I thought you said 1 is 1 and negative 1.
No, we're not there yet. We're not there yet. Just wait. Okay. Like this is we learned this in grade 8. How do I graph y equals 2x? I put in x values and I solve for y. And if it's just 2 times whatever the x value is, that's what I'm doing. That's the first thing that we learn when how to graph is you substitute in. We actually do that in grade 10, input, output. Okay. So I'm at that point right now. We're all good. Any questions? All I've done, take the x value times 2. That's it. Now, I'm going to take...
Isn't a quarter times 2 1/2 on an 8?
I thought that.
Yeah.
My bad. So right here, I told you, get your calculator out. Help me fix it.
Same with like
Okay.
all the fractions.
Oh yeah, these fractions are wrong right here. I was thinking times 1/2 and not times 2. All right, so this is what you were talking about or what?
Yeah.
Okay, so negative 1/2 times 2 should be negative 1. Then this is negative 1/2 and this is negative 1/3. Does that look right?
Yeah.
Can I write it down properly? Okay. So then over here, it's going to be 1/3, 1/2. One. Are we good there now?
Yeah.
Yeah, okay. And actually that makes sense for my graph the way it is. My apologies. Here I am chirping you about your calculator and I do it all wrong. What a jerk, eh? Okay. Now, so any questions about that? I need everybody to be on the same page here. I just took the x value and I times it by 2. We're okay. I need to know this. Because now the next step is to take 1 over all the y values. The next step is take 1 over all the y values. So I take 1 over this, negative 1/8, negative 1/6, negative 1/4, negative 1/2, negative 1, negative 2, negative 3, 0, 3, 2, 1, 1/2, 1/4, 1/6, 1/8. Okay. All right, put that in your y. So all I did is take the original graph and take 1 over those values. So I got a lot of fractions there, right? Anybody want to put those in? Make sure you got it right in your book. Okay, are we still confused? Anybody confused in here? Only me. No? Good? Okay. So to graph this, it's freezing in here. Okay, to graph this, here's what I want to do now. I want to take all of these values that are out here. So that's when my x is growing. My x is getting larger. As my x gets larger, so I'm focused on all of these values that are greater than 1 right now, because I know that 1 and 1 is this. What is happening as x gets larger? What's happening to my y values? No, it doesn't.
It gets to 8.
You're on the wrong one. I want you on the right side. The 1 over graph. Okay, so what I'm talking about is right here. This is the spot I'm talking about. What do you notice? It's hard to see, so let's go back to the big page. What do you notice down here? As x gets larger, what is happening with my y's? They're all getting smaller. We all can agree on that. Okay, so then to graph this part of the graph, this is the old graph. To graph that, I draw it down like this. Now those numbers are going to get smaller and smaller and smaller. But what is the one value that it's not going to hit? It can't hit 0. It can't hit 0. So that means that this graph right here is going to approach this line right here. It's going to approach that line, but it's not going to hit it across it. Got me so far? Okay. Now, going back to this guy again. Now, let's look between my y value here. How do I want to do this? I want to explain this to you. Okay. All right, so this right here, this graph, this green part of this graph, right there, is 1 over all of these values. I'm okay to say that. So these values are all larger. I took 1 over them and they all became fractions. So that's that part of the graph. Now, the second part of this line in the positive here is right here, from here to right here. So between that and that. Those values are all fractions. Yeah? So those are these values right here. Those values are all fractions. When I took 1 over those values, what happened to them? They changed the whole numbers. They got bigger. You would agree with me? So between 0 and 1 on your y, when I take 1 over a fraction, it becomes a whole number. Yes? So to show that on this graph, this little section right here is going to go up like this. And again, they're going to get larger. So a half became 2. A third became 3. A quarter became 4. A sixth became 6. So all those fractions on this part of the line between here and right here, all these red ones right here, all fractions, when I took 1 over them, they all got bigger. They all became whole numbers. That's reciprocal function. Now I do the same thing on the negative side. And I draw it like this. And that's it. Yeah. Yes, you do. You have to show where it crosses at y equals 1 and y equals -1. Other than that, you just have to shape it. And the shape will never change. It stays the same. Okay? So that is how we get to this. The easier way to do it is to just simply take the graph, mark off where the original graph hits y equals 0. So that's an x-intercept, right? Mark off the vertical asymptote at that coordinate, okay? And then I mark off where the original graph crosses 1 and -1, because those are also going to be on my new graph. And then from that point, I shape it. So if it's larger than 1 to begin with, then they become fractions. If it's between 0 and 1 where they're fractions, they become whole numbers. Okay? So let's fill in this chart on this next page now. So you should have graphed it. You should have drawn your graph, this on your graph. Okay? Now, what is the domain for the graph? Let's just work y equals 2x. What's the domain for y equals 2x? X is an element of all reals. What's the range? Y is an element of all reals. Fill that in your chart. What are your asymptotes?
1 and -1.
There's none. I'm talking about this line right here, aren't I? Y equals 2x? That's that line. There's no asymptotes. It's just a line. Can x equal 0? Yep. Can y equal 0? Yes. What happens to the y value as x increases in value? What's happening to the y value on the red line here? As x gets larger, what's happening to y? It's larger. It's an increasing function. What happens to the y value as x decreases in value? Gets smaller. Is there invariant points? No. Okay. Now, let's fill in for 1 over 2x. What is the domain for 1 over 2x? Again, I went through this with you last week. What is the domain for y equals 1 over 2x? This green graph right here, plus asymptotes, what is the domain for it? We went through it last week. What's the domain? Okay. Anybody wants to guess? We're all too scaredy pantses.
Is it greater than 1 and less than -1?
Good. You're on the right track. It's not, but you're close. How is it different than the original? How is it different than y equals 2x? What's the one thing that's different? No, because the curve's still far right, far left. So what's the one difference? What's the difference between the red line and the green line in what x values are hit?
X cannot be a 0.
So that, what is that?
X never hits 0.
X on the green graph does not hit 0, does it? Right? Hits every other x value, which means then that x is an element of all reals, but x cannot equal 0. So your domain for this graph, x such that x is an element of all reals, but x can't equal 0. There's your domain. How is your y different? How is your range different? No. That's correct. What is it? It's the same thing except you put y in there instead of x. Okay. How many of us struggle with domain and range? Yeah. Most of us do. Okay. So the first question I ask you in grade 10 when I teach you domain and range. How far left does the graph go for domain? How far left does this graph go? What does that arrowhead tell us? It goes to negative infinity. How far right does it go? It goes to positive infinity, correct? And then what happens in between there? Right? There is a spot, a blank spot on your graph at x equaling 0. Right? So if it goes to negative infinity and positive infinity, then and it hits every whole number, or every number, not every whole number, every real number, then you would say x is an element of all reals. But then we notice that it doesn't hit x equals 0, so we got to write that in it. Well, but then x can't equal 0. Why are you saying 1 and negative 1? I don't understand that.
Those points, like that's where it goes. So then
Okay,
all
but
those values from 0 to -1 and 0 to 1 would not be hit.
all right, let's discuss what this arrowhead here and here means. Just those two. This arrowhead means that it goes forever to the left. You agree with me, right? This arrowhead is moving gradually closer and closer to this line. So it's still moving to the right. It's hitting every possible value to the right. But we can't hit that value where it hits 0. And then we pick it up again over here. This guy is going as close to left as we can. We keep moving left, 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 but I can't hit that spot. This one moves to the right forever. So the only part of the graph that it does not hit is x equals 0. Well, kind of get that now?
So always.
Yes, that's correct. Now, if your graph may move, it could. So let me just see where they go next. Yeah, okay, I thought this. All right. Before I go any further. Okay, well, actually, we should have filled this in. Can x equal 0? Oh, no, start with the asymptotes. What are the asymptotes in this question? That's the equation of the lines that can't be hit or crossed. What's the equation of the two lines? y equals 0, x equals 0. Those are your two asymptotes. Now, treat the asymptote the same way you treated the axis of symmetry in a parabola. What was the axis of symmetry in a parabola? It was the line that divided the parabola into two, correct? And then you said it was the x equals the x value of the vertex. Yes? Okay, now this one is x equals wherever it can't touch. No, it's not. I'm going to get to that in a second. But that's what we got to remember. So x equals 0, y equals 0. Those are your two asymptotes. Can x equal 0? Next question. No. Can y equal 0? No. What happens as x increases out here? What happens to the y? It decreases. So x is getting larger, right? X keeps going this way, it's getting larger. Would we all agree that it gets larger going this way? 2, 3, 4, 5, 6, 7, 8. It's getting larger. But then this becomes 1 over 2, 1 over 3, 1 over 4. So it's getting smaller. And then vice versa. What happens to the y value as x decreases in value? So what's happening here? X is decreasing, getting smaller this way. What's happening to the y? Same thing, right? Decreases. Okay? Invariant points. What are the two coordinates that are on the red line and the green line? -1 and -1, and 1 and 1. That's right. These two coordinates right here are the two invariant points. They are the same thing. All right. How are we making out? Do we have any questions I need you to ask? Because we have to get into parabolas and reciprocals of parabolas. So if we can't draw a simple line and do that, we can't go into parabolas yet. So anybody lost, questions, unsure of anything on this graph here before I move to the next graph? I'm going to do one more graph of a line. Yes, Megan?
The one like it moves. Like
I'll show you the move one. Just give me, let's just deal with this one. I'm going to do the move one next. Okay?
So how do you know, like, so when it crosses 0, like,
Mhm.
then that's when
That's where your asymptote is, your vertical one. Okay?
when that tells you if it can be 0 or not.
Okay. Are we okay? Any other questions? Some of us, our biggest struggle since grade 10 is graphing. It is what it is. All right, let's look at a graph like this. F of x equals 2x add, I'm going to put this as 2x add 2. Okay? So, just pencils down for a second. Just for a second, all right? Actually, what I want you to do, yes. What I would like you to do, though, looking at any of the other stuff, all I would like you to do right now, please draw that. Okay. Where did you start? You can't graph that? Yeah. I don't know, you should graph that line. Where did you start? And?
Two.
0 and what? 2. Right there. Where do I go from there? up to right 1, right here. Match up. Get it? I just drew that in myself.
So we don't go down now, or we just go.
You could. No, you could go down 2 and left 1. It would get you, it's still on the same line. Okay, remember this. Like what's your slope on that? What is that slope? What's in front of the x? That's your slope. 2 over 1 is your slope. Whatever's in front of the x, 2 over 1 is your slope, right? So you can go up 2, right 1, or you can go down 2, left 1, because a negative divided by a negative is still a positive. Okay? Follow me? So, I went up 2, right 1, go down 2, left 1. Actually, I made this wrong here. Oh, I see that? Okay. But you absolutely have to be able to draw that. Like, we have to be able to draw at least a line to start with. Otherwise, we're going to be in tough on drawing this. Okay? So, in the first point I start with is 0 and whatever that is. Right? This is y equals mx plus b. So 0 and whatever that is. So 0 and 2. And then whatever's in front of the x is my slope. It tells me where to go. Got me? Okay, draw a line. Summer, do you know how to do that? Okay. Now, again, you are welcome to do whatever you like at this point. But I'm telling you, in 3 quick steps, we have the new graph drawn. We want the reciprocal of this graph. So I want g of x. How's that? Okay? That's what I'm looking to graph now. 1 over that. So the first step that you do is you find out where it crosses the x-axis and you draw a vertical asymptote in there. Where is it crossing the x-axis? -1. So I just do this. Now, my next step. And again, I'm focused on the red graph right now. I am graphing where the red graph crosses when y is 1 and where y is 1 and y is -1. So I'm going to mark that in. So that is right here and right here. So that's where y equals 1 on this graph. Don't follow?
Looks like the one above that was like half. The one in upper.
So right here and right here. So like I've got this red line drawn. And my graph paper, I look and I match it up with where y equals -1 and where y equals 1. You follow?
Yeah.
Okay. Now, as x gets larger, what happens to y? As x gets larger, what happens to y? Okay? No? In the original graph, yes. On the red graph, yes. But on the new graph, so what I'm doing now is I'm looking at all of these points. So as soon as I get to here, how do I graph 1 over all of those? They all become fractions. So I go like this. And what about all of the coordinates between here and here, which is between 0 and 1? They're all fractions. What happens to them? They all get bigger. They all go up like that. And then over here, same thing. Now, I am going to point out one thing only. That's the whole graph right there, girls. It's weird. There's no boys in this class. I just noticed that. There is only 3 steps that you have to do, and this doesn't change for a reciprocal graph. Okay? Now, I am going to show you one thing that I need you to figure out because it's going to change how you do a problem in a second. And that is this. Where did I start this graph at? At the y-intercept. And what was the y-intercept? 0 and 2. Okay? And if I'm taking 1 over the y value of that coordinate, it becomes 0 and what? I'm taking the 1 over the y value of that coordinate. What's the y value of that coordinate? So what's 1 over 2? It's a half. This is your new y-intercept right here. 0 and 1/2. Okay? All right. I'm going to rip a few of these off so that you can see them. It's exactly what we're doing right now in grade 8. All right. Y equals. And I just want you to watch and talk. Let's go 3x minus 6. There we go. Okay. All right. Now I'm going to work with you. What is the starting coordinate of that graph? Okay, I want you, when I ask you for a coordinate, I want you to say 0 and -6.
0.
Okay, you got that right. Now, what's your slope tell you to do? Okay, great. Okay, so 0, -6 is my starting coordinate right here. Yay? Now I'm going to go up 3 and right 1 of that coordinate. Okay. Oh, don't be like this. You work and then you don't work. Darn you. So up 3, these are obviously 2's. Okay, so I go up 3 and right 1 to get to wherever I got to get here. Okay, so those are my 2 coordinates. Now, you've drawn that graph. Now I want to draw 1 over that graph. What's the first thing I got to do? Asymptote where? Where it crosses the x-axis. So the first thing that I'm going to do then, I need it right there, right? X equals 2. There's my y asymptote. Got me so far? Any questions? Then I got to mark off what? Y is 1, y is -1. Okay, so now what I'm going to do is I'm going to graph now y equals 1 divided by 3x minus 6. There's your graph. Now, looking closely at that graph, look at there. It even shows you where they connect with your original graph at 2/3. 2 and 1/3 and 1. You don't have to be this precise. 1 and 2/3 and -1. Those are your 2 coordinates. What is the equation of the 2 asymptotes? Nope. Y equals 0. It's still that horizontal axis.
Oh, your y never changes.
No. Yes. For us. For this class, yes. Okay? And then x equals what? 2. Okay. Let's try a different graph. Okay. Where are we starting? 0 and 1. And where am I going from 0 and 1? Up 1, right 3. All good? Okay. Here's my y-intercept. Here's my x-intercept. Graphing 1 over this. I'm going to take 1 over that. Where is my asymptote? My vertical asymptote is at x equals what? -3. Okay? Okay? Now the problem with Desmos, no asymptote is drawn in horizontally. What do we say? -3? There you go. So there's your horizontal asymptote. Right here, again, there's where your 1 and your -1 is. And Desmos is showing you that because that is the intersection of the two graphs. And they will always be at y equals 1 and y equals -1. Because what's 1 over 1? 1. What's 1 over -1? -1. Okay, are we better? I think, are we good with this? Because I'm about to get into the parabola part, which is going to cause you a little bit of grief. Are we okay? Allie? Are you sure? Okay. You gotta tell me if you're not. I'm trying to make sure we got on the same page here. Okay. Now we begin. Now where it gets complicated is this. Okay? So here's what I have. I have y equals x squared subtract 1. Again, here's the thing, ladies and ladies. There is no gents in here. Certainly not me. Okay. Here's the thing. We have to be able to graph a line in this class, and we have to be able to graph a parabola in this class. You have to be able to do those two skills. Like, it is absolutely necessary that we do those two skills and do them well. Because you can't do the rest of it if we can't start at the basics. All right? And we should be able to do those by now. We have been doing so many of them. All right. What is the vertex of this graph? Thank you. Your vertex is right there. 0 and -1. Remember. And again, these are things that I want you to instinctively be able to do immediately. When you're in a parabola, in vertex form, the h is in the brackets, the k is outside the brackets. If there's no h, it's 0. The k is -1 here. All right. Now, I'm not expecting you to, well, yes, I am. I lied. Now what happens? I need a point to the left and a point to the right. So you can solve for your x-intercepts here. That's what I expect you to do. You can also pick a coordinate to the left and a coordinate to the right. So what's one coordinate to the right? 1. Put 1 in that equation there. What is 1 squared? What is 1 subtract 1? 0. So this graph looks like this. All right. Now. Okay. Are we good so far? Y equals x squared subtract 1. Again, I'm not spending a ton of time on it because I expect you to do it. We have spent 2+ months on graphing parabolas in both the 2 classes. All right, what's the first thing that we do after we have done this? Asymptote. How many asymptotes are there now? There's 2. There's 2 spots where y equals 0. So, pour it down here, put it down here. Those 2 asymptotes. Okay. We good so far? What's the next step of the 3-step process? Okay. So where does y equal 1? Right here and right here. That's where y equals 1. Where does y equal -1? At the vertex. Okay. Good so far? All right. Looking at the green graph, for all of the values that are larger than 1 for y, above the 1, they all become what? They're all larger than 1 right now. So when I take 1 over them, what do they become? They all become fractions. So the next step is this piece and this piece all go down here like this. I'm taking 1 over these y values, 1 over these y values. Now, what about from here to here? What happens to those values? They become whole numbers. Goes up, same here, up like this. Now, the bottom part is a little bit trickier, but not really. This is where y is equal to -1. This is where y is equal to 0. Yay? Which means that all of these values down here are what right now? They're fractions. They're negative fractions. So what happens to a negative fraction when you reciprocal it, take the reciprocal of it, or take 1 over it? It becomes bigger numbers, right? So I finish this graph off like this. There is the graph of y equals 1 over, I should have wrote that up here. One over that. 3-step process. Number 1, mark your asymptote. Number 2, mark where y is equal to 1 and -1 because those are your invariant points, and then just shape it after that. I did forget one asymptote. I do want this drawn in each time as well. Don't forget that. That is an asymptote as well. All right. What are the equations of your asymptotes here? Y equals 0. X equals 1. X equals -1. What is your domain for this graph? Very good. X is an element of all reals. Same. But what can X not equal? Where are your 2 asymptotes? 1 and -1. What's your range for this graph? This one's a little trickier.
It can't go between 0 and -1.
Okay. So this This is different. So let me put this in here. Oh, got my fat guy here. I'll do that right here. All right. You may want to write this down. For this one, I'm going to write it as such. Y is greater than 0. So remember, I am describing the graph to somebody. That's the red lines. So the lowest it goes up top here would be 0, and it goes up forever. So that's y is greater than 0. What about down here? Y is less than or equal to -1. And then I would put this in here, just for good measure. All that does is tell you that it's a continuous line. Okay? All right. That's reciprocal functions. There are 2 chapters left. We will take to the end of this week to finish all of 7.
When you're building, like,
Yes.
it can't equal 1 or -1, because that's sort of like pass and towards that. But then, like, it can't go between those two also, right?
Yeah, it does.
It still goes like past that.
This is going left forever. This is going right forever.
If that one wasn't there, then.
That's correct. Then you'd have to say y is greater than 1 and y is less than -1. Okay, so we are going to finish up 7 this week. That leaves us with 2 to go. 8 and 9.
Are we like testing or assessing?
Yeah, we'll assess on this probably Tuesday next week. I gotta go, yeah, probably Tuesday. I'll be away Thursday, Friday, so we'll test that. I know most of you girls are away too, so. Okay. Look at the previous work. I know most of you didn't start 7.4. Is there anything between 7.1 and 7.3 that you need to go through while we're still here?
Question 10 on page 307.
What does this have to do?
What's that?
What does this have to do with like what we started off with? Like,
Absolute values. They tie them in together because in grade 12 you use both of these graphs.
Like we don't have to like
So like
have the absolute value.
so like okay, so here's what you're getting. In grade 12 you're gonna see this. And I'm gonna ask you to graph that. Okay? So you start with your graph of 1 over x. So you start with 1 over x. And then you have to move it. So I take 3 key points. So this is all grade 12 work. I take 3 key points. I take -1, -1, 0 and 0, which is my asymptote connection, and 1 and 1. And I have to move them. So what I do is this changes it by timesing everything, all my y values, by 4. So I go like this. -1, -4, 0, 0, 1, 4. So my new coordinates, these guys are not going to be at 1 anymore. This will be 4 here, and this will be -4 down here. But I don't put that in yet. Now C moves everything 3 to the right. So I go 2, -4, 3, 0, 4, 4, and then D moves it up. So I do this, 2, -1, 3, and 5, 4, and 9. So now, on my graph now, 3 and 5 is the intersection of the asymptote. Okay, so I go to 3 and 5. There's 3, there's 5, like that. I go to 2, negative 1. 1, 2, negative 1, so down here. Draw that. Then I go to 4, 9, somewhere up here. And draw that, like that. So you need to learn the very basic 1 over x graph so that I can translate that graph now without any issue. That's my C, that's my D. C and D, that moves everything left and right. That moves everything up and down. That's a stretch vertically. So now the alternative is, okay, well then we're going to do the same thing now. This time I want the absolute value of x minus 2 plus 4, so something like that. So now I got to translate this 2 to the right, 4 up, the absolute value graph. So you start with your absolute value graph, which is like this, and I'm going to move it 2 right, 4 up. So we have to work with these basic graphs to get the understanding so that in grade 12 we can move them from their original spots. That's why we tie it all in together. Okay? And that's the first thing that we do in the first section on transformations of graphs. You wanted question 10. If a company can build between 16 and 32 movie screens, what is the number of screens within this range that will give you the maximum profit? All you need to do is put 16 in and 32 in, okay, and solve for it, and that'll tell you what the range is for the maximum profit, and then subtract them to get the range. Okay, now you could draw that out as well, and then put in 16 and 32, and then find your profit. That's actually what you would do, is what is the amount of the profit you would figure out after. But that's it. It's just substituting in for x and then solving and then subtracting. Okay, other questions from 7.1 to 7.3?
Question 7 on 292.
Okay, so you're doing piecewise here, right? Okay. Let me do this right. Y equals minus x squared plus 2. And then this is minus x squared plus 2. And then comma. Okay. So your graph. All right, let's start with the original one. So the original is minus x squared plus 2 would be this right here. Agreed? What is this spot right here and here? What are those two coordinates? Looks like negative.
Negative 1.4.
They look like 1.5 and negative 1.5.
Okay.
Agreed? Okay. So this is negative 1.5 here, and this is 1.5 and 0. So I'll just do this and 0. Okay. Okay. So looking at your graph, what part of that graph are you using? What part of this graph appears in that one on your page? Explain it to me using the domain.
Let's go for x. Wait,
Okay.
Is less or greater than negative 1.5.
Yeah. You're using this part of the graph, are you not?
Yeah.
So how do you explain the domain of that?
X is less than or greater than negative 1.5, and then 1.5, and then x is less than 1.
So there you have it.
Okay.
okay?
Yeah.
That's the only part of the graph you use, is between here and here. All right? Now, this other graph, I'm going to draw it in red, is actually this part here and here. So what part of the red graph do you use to get that graph?
And it do the same thing?
No. You're still using the negative a half and a 1.5 and 1.5. You're still using that, but you're not using in between them here. You've already used the in between for this other graph.
Oh, okay, so then it would be x is less than negative 1.5, and then x is greater than 1.5.
There's your
All they
answer.
have in the after that one is x is greater than, like, say, 1.5. Like, why didn't they put in the other?
I don't follow your question. Say again.
In the back of the,
Mm-hmm.
all they had was x is greater than 1.5. Say what you use. Why, like, didn't they include the x's less there?
You should have. You should have, because you're using those two parts of that graph. So I don't know. I didn't. What is that? If I'm looking for the answer, we are talking about what? 7.2. Question 7. Oh, okay. No, you're wrong. They used both. And that actually is root 2.
Yeah.
Right? So like, which I should have been able to figure out, but
You have to do that. But it has to. Like, you want us to write it as root 2 or the?
yes. No, because it doesn't cross at 1.5.
Oh, like it crosses.
It crosses at root 2, right? Like 0 equals negative x squared, add 2, subtract, divide by negative 1, x is equal to plus minus root 2. So that's where it crosses at. So yeah, you should have used that instead of 1.5. I was just looking at the graph and it looked like 1.5, but it's actually root 2. Okay? You're taking a part of two separate graphs, hence the piece, and you got to explain to me using domain what part of each of those two graphs used to make the new graph. Okay? So the second one's a little bit harder because you'll have to find the equation of that graph. So that second one, let's extend the down. So it's got to go down to 0, and so it'll be down to 1 and 2. So I'm going to draw this out for you so that you can. Okay. So there's my two graphs. Now here's the thing. You need to first find the equations of those two graphs. Okay. So I'm going to use the red equation first. What's this vertex here? Okay. So that equation of that graph then is x minus 1 squared subtract 2, which means this guy is like that.
In the back end, two of the x.
Oh, okay, they made it complicated. All right, so here's what I have to do then. So I have that. I have to solve for A to get to that 2, all right, which is what we've done before. And then I would piece it together. That's quite a bit of work actually for that little bit of question. So, okay, we will work on this. If you can put a little time on your own into it. We're already on Wednesday, aren't we? So like we had Thursday and Friday to clean this up. Back to your assessment question. I'll